All right, we are live. So everyone, welcome to the winners live stream for wave pool number 6, which happened over the course of February. We had an assortment of awesome projects, and we're lucky enough to have the top 3 projects from the February wave join us here today to walk us through the projects, what they built with, and give us a rundown. So without further ado, I'd like to turn it over to Henry, our first place project from the February wave. We'd love to hear more about your project.
Awesome. Thanks for the intro. Hello, everybody. So I'm going to show you guys a little bit about my project. It says I can't share my screen here. Hold on 1 second. Okay, never mind. Okay, it's working now. So I'm going to talk a little bit about my project for the February wave pool, which is FluBid. FluBid is a NFT rental protocol that does pricing via auction, payment via Superfluid, and it can support a wide variety of different assets. So in FluBid, there are 2 main components. There's the rental auction part and the controller part. The rental auction handles the more complicated stuff of the bidding and the streams and the payments and all of this stuff. And you can pair that up with a controller to get different configurations. So one type of rental auction is the continuous rental auction, which is any bidder can create, update, or delete a Superfluid stream to the auction contract. And then the auction contract will keep a sorted list of all the bidders, and whoever's at the top of the list is the current renter of the NFT. So it's pretty volatile. Like, the bidders can change at any time, the renter can change at any time. So you wouldn't want to like rent an apartment or something with this. It's probably more suitable to something like a game item would be pretty fun, I think, to rent with this. In contrast, we also have the English rental auction, which has 2 phases. During the bidding phase, all the prospective renters can place their bids, and whoever wins that auction secures the exclusive right to rent the NFT for some minimum and maximum duration. So you can take one of those and you can pair it up with a controller to handle the specific asset that's being rented. So when an NFT owner creates a rental auction, they deposit their NFT into the controller that they've deployed. So for example, like if you were renting out a lens profile, the controller would expose this post function that would allow the current renter of the auction to post stuff. Or say you had a 4907 token, which is 721, but with an extra user role. This would get called by the auction contract when the renter changes, and it would just set the new user. And as you can see, like, these are both really small contracts. So if you have a 721 token, you can create new controllers really easily. For a diagram of this sort of architecture, you can go here. These are the FluBid. This is the FluBid documentation, by the way, which you can find via the front end, which I'll show you in a minute. But the NFT owner goes to the factory. They deploy these things. The bidders interact with the rental auction. The owner interacts with the controller. They communicate. There are streams sending around, and the controller reacts to the renter changing. And as you can see here in the continuous rental auction, whoever's not at the top of the list, which is this guy right now, gets a stream sent back to them at equal rate. So their flow rate is 0 if they're not at the top of the list. But if you are at the top of the list, you're paying the owner. So that's kind of the overview of how it works. I made this front end with React. You can check it out at flubid.eth.limo or .link or whatever. So I made this continuous rental auction for this, fake game item. And I have a bid in, 318 has a bid in at 1 per day. And the current top bid is 1.06. So like I could update mine to go 2 per day or something. I could update that. And then 318 would be the new renter. So if we go to like the Superfluid dashboard, you can see this is 318 here. They're streaming to the auction contract, and the auction contract is also streaming back to them. So their balance isn't changing. But if you go to the current renter, then you can see they're streaming to the contract. The contract is then streaming to the owner of the NFT. So in addition to bidding on others' auctions, you can check out your own, you can create new ones, and you can also check out the documentation from here. Currently, it's only deployed to Mumbai and Gurley. I will deploy it to main network soon, but I want to do some more like testing and stuff. And there's also some gas optimizations that I want to do. So that'll be soon, but not quite yet. If I have time to check out the code a little bit, I'll do that. So here's the continuous rental auction. It's a super app, so it can react to streams and stuff. Here's the linked list struct here. It's doubly linked list. Constants, non-constants, bunch of stuff. And the cool things happen in the super app callbacks. So when somebody creates a stream, they're placing a bid. And so it'll do a bunch of checks here. And the cool thing is when you place a new bid or you update a bid, you have to pass your position in the linked list so the contract doesn't have to search through the whole thing. So that's what's happening here. And then it'll insert you in there, make sure that it's all in the right place, update the flows and whatnot. And the other callbacks are similar. We've got pause and unpause, which can be only called by the controller. And that's about it. The English auction is similar, also a super app. You've got 2 functions to place bids. This one gets called by the Superfluid host, so you can use it with a batch call to approve the contract to take a deposit for that minimum rental duration, approve it as a flow operator to create the stream when you win the auction, and then call the bid all in one transaction, which is pretty sweet. And then you've got some other stuff for reclaiming deposit, transitioning between phases, and that sort of stuff. And here I've showed already very simple controller for 4907 tokens that inherits this ERC 721 controller, which handles like sort of the basic stuff, like we have to have the NFT in order to start the auction, and that sort of thing. And then finally, the last piece of the puzzle here is the factory, which you can pass which controller you want. It'll clone the auction, it'll clone the controller, register the app, and initialize the clones. So that's FluBid. Again, if you want to go check it out, it's only on testnet right now, but soon it'll be on mainnet. Go to flubid.eth.limo. And Thank you very much.
Awesome. Henry, that was an awesome presentation. I think it was an awesome use case to see, especially like how elaborate you got with the smart contract. You put up a super app. You really got into the weeds with Superfluid and Solidity. So hats off for that. I also like the concept. I think one of the first kind of I think marketing splashes Superfluid made was we put up a bunch of NFTs and you could do a stream auction for them.
Oh, really?
And so that was kind of like one of the earliest kind of creative use cases that we saw ourselves, and I think is really cool seeing you kind of like build off of that and take it a step further. So great work here, Henry. Congrats on the first place in the
Thank you
February
so
wave.
much.
Awesome. We'd love to turn it over now to Piotr and his project Sentinel DAO, which gets into one of the most important parts of the Superfluid protocol and money streams. So Henry, sorry, Piotr, the floor is yours.
Yeah, thank you, Sunny. And first of all, I wanted to congratulate Henry on his first place and really say that I'm super impressed by your work and the whole concept and how fleshed out it was. So yeah, congrats, man. Right, so let me share my screen and get straight into it. So that's supposed to be live now. All right. Right, so Sentinel DAO. So in order to understand what we've done here, first you need to understand a little bit more about how streams in Superfluid work. And just in terms of time constraints, I will just be going over the FAQs and the whole concept of the Sentinel DAO without actually going through all the transactions and actions that you can do with it. So first up, it would be good to understand what a Sentinel is. So if you were to go to the superfluid.finance website and send a stream to some address, you can input your flow rate right here, and then you have this pop-up window that says that you put up a buffer in order to open that stream. So you might want to ask what's happening with that buffer and what's it used for. And so it's used for ensuring that the stream, even if your account runs out of funds, will still have some tiny amount of funds to continue and then in turn to be closed. So if you wanted to learn more about that, you can go to the docs of the Superfluid. But it's really well explained here with this diagram, which states that as long as you have some available balance, your stream will continue to flow. And then once your available balance runs out, that's in your account, then it's going to be streamed from your buffer. So that's where this comes in. And this stream, once your account balance goes down to 0, is then subject to be closed by a Sentinel, who then in turn would cash in on that balance and basically collect that as a reward for monitoring the network and making sure that there is no insolvent streams. Right. So in principle, you can think of Sentinels as Sentinels in the Superfluid ecosystem as validators in the Ethereum ecosystem, or miners in the Bitcoin ecosystem. They're basically doing essential services to the network to ensure that everything is well. So the next question you might want to ask is how to become a Sentinel. And in order to do that, you have to put up a stake. So we've created this fancy little table to visualize some of the Sentinels, because each and every token has its own Sentinel. So DAI has a separate one, ETH has a separate one, and so on and so forth. And in order to become the next one, or in order for you to become the Sentinel, you need to put up a stake that is higher than the current stake of the Sentinel. So if I wanted to become the Sentinel for the DAI super token, I would need to put up more than what they have at stake, and then I would be able to close insolvent streams and collect the rewards. So then the next question you might want to ask is, how profitable is it to run a Sentinel unit? So we've actually calculated that in terms of, and there are two caveats that I will come to in a second, but basically you can think of that stake that you put up to become a Sentinel as your initial investment that is needed to kickstart things. And then the returns that are collected from closing the streams, from those buffers, you can think of them as the return on your investment. So if you sum all the rewards for different tokens and divide it by the current stake, then you get an estimate of the APR. So you can go over to toga.superfluid.finance, and here you can check out different tokens on different networks and get some more data on those Sentinels, how big their stake is, what's the current pick, or what's the current Sentinel, and so on and so forth. And you can also see the rewards that have been collected in the past days. And you can see that most of the rewards are actually very tiny. So they are not even $1 for USDC. And the same also goes for the DAI super token. They're not even $1. They're not even a cent in most cases. So what that means is, for example, let's take this latest reward that the USDC token or that the Sentinel collected. And you can see that the transaction fee for that transaction was actually 6 cents. But the reward for that transaction wasn't even 1 cent. It was like 100 times less than that. So in terms of our Sentinel DAO, we would call this transaction an unprofitable transaction. An unprofitable transaction that is actually losing you money, because you're getting this much, but in order to get this much, you actually have to pay that much. So it's not profitable to do that. So so that's a bummer. But worry not, because there are also other transaction types that we have called jackpots that represent transactions that are very high reward, which when you close, it actually makes up for a lot of the unprofitable ones and gets you something on top. So for example, this transaction, or maybe even this one, we would count as profitable transactions, and not only profitable as jackpot transactions, because they're so much more than the unprofitable ones. So for example, this one was $5.50 that you got, but you had to pay 40 cents. So the gross profit would be about $5.10. So we've summed that up for the past 30 days and 7 days in terms of APR, and the same goes for the jackpot transactions and unprofitable transactions. So this is a nice sort of overview to have an idea of how profitable and how sustainable your investment is. And one point that I want to draw some attention to is that, for example, the difference between the DAI super token and the USDC super token. You can see that the stake currently for the USDC is very high. Actually, if I refresh that, it's gonna get updated to the should be updated to the right value. We've also made a similar table for Polygon. Yeah, exactly. So you can see that the 7-day APR and 30-day APR are a lot more, sensible for the USDC token, and that those for example, ETH or DAI are kind of weird, and especially for DAI. So the reason for that is because the stake is so minuscule. If you actually take a look at how we calculate it, we divide the APR. So in the calculation of the APR, we divide by the stake. So the lower the stake, the higher APR is going to be. And the APR for the 30 days is so high because if you scroll down in the DAI transactions, you can actually see that that in the last days you had an $8 jackpot, and before that, I don't know if that's more than 30 days, right? Yeah, that's the 2nd of. I'm a little weirded out by the. Okay, so that's February. That's the 4th of February. So that would be more than 30 days. But if you take a look at that $8 or that $1 and compare that with the stake and extrapolate that to a whole year, if that frequency of closed transactions keeps up, you're gonna have that high of an APR. So it really depends on the stake of how high it is, and on the percentage of jackpot transactions in the whole transaction pool, so to speak. Right. So that's how that's what a Sentinel is, and that's what it does. But there are some problems with it, or some missed opportunities, so to say. So, for example, the very obvious one is, let's say you have 2 people, Alice and Bob. Both of them have $10,000 that they can potentially invest to become a Sentinel, and they start to outbid each other. So first Alice is the Sentinel and Bob wants to become it. Then Bob outbids Alice and he is the Sentinel, and Alice wants to become the Sentinel. So they outbid each other in some sort of bidding war. And at the end, only one of them can potentially be the Sentinel. And that has some drawbacks connected with it. For example, first of all, you have to constantly monitor if you're still the Sentinel or not. And if you're not, you have to outbid your competitor. And second of all, and most importantly, by making the stake higher, you actually lower the APR because you have to invest more, and you're still getting the same number of rewards that you collect for closing the streams. So putting more to the stake isn't actually that profitable. But you have to do that if you want to become the Sentinel and be the Sentinel and remain as the Sentinel. So let's say if Alice had $1,000 and the APR was 12%, then after the bidding war, if Bob puts 10 times more, the APR drops also by a factor of 10. So that's not so good if you have 10K on 1.2 APR. As when you had 1K on 12 APR, that's 12% APR. That's much better. So that's one scenario where you can have some competition and some missed opportunities. Another one is if you, for example, have 2 people like Bob and Carol that both have $600 and a Sentinel, for example, Alice, that has $1,000. So the 2 of them can have an agreement and pool their funds and become the Sentinel where one acts on behalf of the other one. So, for example, let's say that Carol transfers their funds to Bob. So now Bob can become the Sentinel, but he also is the custodian of Carol's funds. Carol has to kind of, count on Bob being a good guy, and also Alice cannot now profit from her funds. And then you can also have, the hassle of running a Sentinel unit, which is a little technical. You have to know your stuff. You have to know, how to set it up. Maybe if you want to be super secure, you want to have it redundant. You have to take care of the EOA wallet that it has enough funds on it. and so on and so forth. So for example, if you were just a vanilla user, maybe that would be too intimidating. And even though you had the financial means to become a Sentinel, you wouldn't do that and you would just walk away. So those are the three scenarios that are maybe even happening right now in day-to-day Sentinel operations. But you can actually solve most of those things, or all of them, if you introduce a DAO. So let's say there was a possibility to pool funds for multiple people in order to become a Sentinel. So for example, in our first scenario, we had Alice and Bob that were constantly outbidding each other, in turn lowering the APR and also being engaged in that bidding war. So the effort of monitoring what's going on and so on. So if they were open to an opportunity of joining their funds and creating a DAO, we can maybe then have an agreement between them where they say, okay, I'm gonna put up $1,000 and so am I, and then we can have $2,000 combined, and the APR is still relatively high. And what's more important, we have $9,000 left that we can invest in some other opportunities. Or for example, in our second scenario, we can have Bob and Carol form a DAO and outbid Alice, and then no one is custodian of someone else's funds. It's controlled by the smart contract. Or we can just have all of them pool their funds and become a DAO as a three, and then everybody's happy as well because they can participate and share the profits. And then lastly, as a DAO, you can delegate some members to some of the tasks, and you can distribute the responsibilities so that one person takes care of the EOA wallet and maybe sets up some monitoring that ensures that it's always funded. One person runs some redundant instances. One person cares for the security of the whole setup, and so on and so forth. So that also lowers the responsibilities that everyone has. So that's basically the concept of the DAO and the benefits that it could bring. And if you want to play around with it, there is also our Girly deployment, where you can basically where you have a smart contract that is set up to become a Sentinel, and where you can throw some funds at it. You can redeem your funds, and then you can simulate closing of the stream. I'm not going to do that now because I think I'm over the time right now, but you can also see the demo on our Puzzle Labs channel. Right, so thank you very much. That was our Sentinel DAO hackathon project.
Thanks, Theodor. That was an awesome presentation. I think, yeah, Sentinels are very kind of like important part of the network, but also like their sort of, I guess, economic kind of dynamic is very kind of interesting, right? Because like you're kind of preying on the downfall of people that are streaming money for profitability. And so in order for it to be like worth securing the network, bad stuff, I guess, needs to be happening on the network. And so it's definitely an interesting dynamic. And to see you guys kind of aggregate the data and demonstrate profitability, and also get the kind of DAO aspect there where you can like, share in the profitability and remove some of that kind of binary element there is to Sentinel profitability, was really awesome to see. And it definitely spurred a lot of internal discussion here at Superfluid, I must say. We're definitely talking about your kind of design there. So great work here, and really great seeing you guys participate again.
Yeah, thank you.
For sure. Of course. All right. So yeah, congrats on the second place, and I'll turn it over to Biddy. Biddy, would love to hear more about your project.
Yeah, hey guys. Can you hear me?
Yeah, we got you.
Okay, I'm so glad to be here, and congratulations to the first place and second place winners. I'm here to present a project about salary bonds, and it's a very simple project that I actually worked on alone, and it doesn't have a really pretty front end, I must say, which I would show just for that. But the contract aspect is which is interesting. So let me share my screen and maybe walk through. Yeah, okay. Can you guys see my screen?
Yep, we're looking at a Zoom window right now.
Okay, sorry. Yeah, there you go. Can you see my Visual Studio?
Yep, we got it.
Okay. This project actually, I built it with 3 contracts actually working hand in hand. And the contracts are a bond market, a router, and a salary bond contract, which is more like a factory for these bonds. So what is a salary bond? Salary bonds are bonds that can actually be put on chain based on someone's Superfluid incoming Superfluid stream. So let's say you have you're paid in using a stream, or you have income coming in through a stream. You can create a bond from that stream and post it on the market and have someone give you upfront money and have them actually entitled to part of your stream. So how it works is actually with the router actually does most of the magic, and I'm sure this is just a normal script that has been there. But with this router, what it does is that it actually just listens for streams and waits for the super app callbacks to give it instructions on what to do. And by waiting for streams is that there are 2 types of streams that come to the router. That is a stream coming in from someone who wants to create a bond, and a stream coming in from the bond contract that creates the stream to the router on behalf of someone who owns a stream using ACL permissions. So in this case, we say that you can actually create a stream on the router and have that stream accounted for on the salary bond contract, or you can give the bond contract ACL permissions to create a stream based on a stream you own to the router, which can be used to create bonds after that. So if you create a stream to the router, what it does is that it automatically creates the same stream back to you. So the inflow and the outflow becomes 0. That is before you create any bond, just to ascertain that, yeah, this person actually has this stream, can actually create this stream to the router, and he owns it before creating the bond. Whereby when someone goes to create the bond, the bond contract, the salary bond contract here, checks if the person actually has a stream being routed on the router, an active stream. Let me show the function. Yeah, creating a bond. Yes, so it checks for if the flow rate actually exists. If not, it's going to check for the ACL permissions. If you have any ACL permissions sent to it, the flows are checked up over here. It calls the router to check the available flow at that particular time on that address. If any of this is available, it's going to actually now create the bond and post it on the market, where anyone can actually come in. Let's say this bond is worth 100 USDC. You can come in with USDC, buy that bond, and transfer that USDC to the creator of the bond, and you are going to be automatically given a stream based on the duration that was put in the bond to occur. And that stream this duration here. It's the stream you're going to be created for when you purchase the bond is going to be based on this duration, which means for every second of a stream you receive, you're going to receive a particular percentage, which is more than what the person is actually entitled to. Whereby if it's if you're sending 100 USDC, you're going to be given, let's say, a total sum stream of 100 USDC plus X percentage, which, as you can see, we have not yet put a custom percentage of the contract. It's still in the process of going into finalizing everything. So you get a stream that will amount to the amount you send plus a percentage that is determined from this amount required by the person who created the bond. So you accepting the bond happens on the market, and I will slightly show the market how it happens. Yes, so this way it happens, you acquiring the bond. So all you need to do is just put the bond ID and approve the funds the bond is worth to the market, and automatically just call this function and you'll receive a stream. So I'm going to show this in on my tests and a little bit using the Superfluid console from the contracts that have been deployed on a LiveNet. So in the tests, actually, I used Foundry, and it's pretty straightforward for anyone going through the document either on GitHub or anywhere else. And what we do, we initialize all the contracts, that is the bond market, the bond contract, a sample test token, which is a pure super token, and a router, which we actually need. Then we set them up, and in the setup, then this here, we're just testing adding at the market to ensure everything is working fine. That's not what we need right now. What we need is to test adding a bond. So to add a bond, you first need to, as I had said, create a stream to the router, as you can see over here. And that stream is what will be like your ticket saying, yes, I own a stream. I'm actually, to prove I'm owning a stream, I'm routing it to the router, and the router is routing it back to me. So that's what happens. And you can see in the assertion, when we check on the flow to the router and back to the seller, the flows actually should be the same at this particular point, because the bond has not been created and has not been purchased yet. So we create the bond on the bond contract. Then we test how we add it. So the first part is going to, how we buy it. The first part is going to be the same from the previous test we just checked. And what I need to show is how it's actually purchased. So as you can see, the buyer over here, we are setting a buyer, and the buyer is interacting with the bond market. So they first have to approve the bond market, the amount that's supposed to be received, then acquire the bond with the bond ID over here. And from that, you can ascertain from that transaction, when you call the flow rate of the router and the buyer, the flow of the buyer from the router, it's going to be, we just said greater than 0, but the real explanation will come on the console, which I'll show in a moment. There is also another way to go about the bond, which is not really the forward way we are talking about. This is more of a backward approach to purchasing a bond. And this is where someone actually goes to the market and posts, yes, I would like to give out X amount of USDC to receive a stream over this period of time. So when they post that request on the market, you can come in and say, yeah, I need 100 USDC right now, and have a stream that can actually amount to more than 100 USDC over a certain duration. So what you do, you go to the market, take the bond, the ID of the person requesting. It's the bond contract. Someone requested with this amount as the amount they're going to give, and this as the amount they expect to be streamed over 30 days, if you do accept that bond. So when you do accept it, what's going to happen is you're going to either give ACL permissions to the bond contract, or again, create a stream to the router that's going to be routed back to you, just to ascertain that you can actually acquire that particular bond. So what happens next is you open a stream to the router as the buyer. The buyer here is the token holder. They open a stream to the router and actually create a bond from offer. And the offer is the offer ID, which we get from the offer that had been requested, this ID over here. So I'm just going to run it locally, just to be sure for now, to show that the logic we've just walked through should work fine on the contract. While it's compiling, I'll open up the console. Okay, there we go. So all the tests we went through, that is requesting a bond, creating a bond, purchasing a bond from a request, or just acquiring a bond from a bond that had been created earlier. All the logic works. So from here, I'm going to show the Superfluid console. And sorry, I think. And just show maybe a live example of what was happening while the routing was taking place, things like that on a live network, from examples I had created earlier.
Hey, Fede, just a heads up, we probably have a little under 3 minutes left for your slot here. Just wanted to give you a time check.
Okay, I go to the console right now, but the contract addresses in the GitHub repo. Check them and actually check them on the console. You'll find that for every stream coming to the router is being routed automatically back. And if required, that stream is reduced on the value is being requested to acquiring the bond, and the routing still continue person who created, the person receiving it. So unless the streams should actually be equal, the person who created the bond is still going to have a certain percentage of this stream active on the router. So I'll leave it at that. And if you need any more information on the project, you can check it on GitHub. Thank you for now.
Awesome. Thanks so much, Fede. Yeah, my apologies. I kind of cut short your presentation a little bit, but great work overall. I think, yeah, the concept of tokenizing those salary streams into bonds is just a really awesome concept. It's very powerful when it comes to kind of taking these cash flows and being able to attain kind of upfront liquidity for these ongoing streams, and create like a sort of market for that. So really great work. I think it's a really neat DeFi use case for Superfluid. In fact, I myself was thinking about hacking a certain kind of proof of concept like that. So if I get around to it, I'll definitely take your project for inspiration. So yeah, congrats on third place finish, and great work.
Thank you.
All right. Yep. All right, so I'm going to turn it over to Shubham with the last 10 minutes we have left to go through SafeX.
Hey, thank you. Thanks, Anil. I hope y'all are doing fine. Like, I see this COVID season and all is starting again. So like, hey Sunny, how's your health after Eat Denver? I heard many got sick.
Yeah, Eat Denver was a very fun and tiring experience, but it was a positive one overall. We met a lot of really cool people, and I think only one of us came back sick. So casualties were small.
Cool. I wish for good health to her or him. So yeah, so like we built SafeX this week. So like basically what SafeX does is like you can like trade your cash flow NFTs which you have. So like let's say there is this one employer and you are working under him and he decides to give your tradable cash flow NFT as a salary. Like your 1 month salary is $1,000 and you are getting a cash flow NFT of $1,000 per month. But let's say you are in urgent need of some emergency funds. So what you can do is you can come to our platform and sell your that particular tradable cash flow NFT to a person and then transfer that particular NFT to him or her or that for it address. So basically, this is how you will set up your tradable cash flow NFT. So like this particular owner. So this is the owner address of the Gnosis safe. So like we have built it with a Gnosis safe. So like what you do is first of all you set up a Gnosis safe for receiving a salary. Why? Because like getting a salary in one particular account can be a bit dangerous, as if your private keys of that particular wallet gets hacked, then your salary stream can also be transferred. So to solve that particular issue, what we did is we created a safe for getting that particular money stream. So as you can see here, this is my safe address. So like first we deployed it on Gnosis, but like we're facing some issue deploying the tradable cash flow NFT on Gnosis. So then we deployed it on Gorilla. So this is, I tried to set up it with Gnosis first, but later I set it up with Gnosis safe on Gorilla network. So like I'll be showing the address on the next part of the video. So like all this information is pretty basic. The owner is the safe address in this case. Then the name of the NFT, its symbol, host, CFA, and accepted token. So like host and CFA are given by Superfluid. The accepted token is DAX for our case. It can be any token which the employer is giving as a particular money stream. So I'll deploy this particular contract. Then like I can create a money stream to this particular safe. So like from a employer's view, you can come here and then start a money stream of this particular flow rate to this particular safe address. So after deploying the particular NFT contract and starting a money stream, so as you can see, this was the safe address, and this particular middle is the NFT with the tradable cash NFT which was created. So what we are doing is particular money stream is being sent to the particular cash flow NFT. That cash flow NFT sends that particular same stream without making any changes to the flow rate to the safe. So now you can come on our platform and like create a sell your salary bond kind of thing. So here, like I'll add basic details about my particular salary money stream. So like how much salary am I getting, the duration of that particular salary stream, and for how much money I would like to sell. And this all information will be displayed to the person who wants to buy this particular salary stream on buy salary stream page. So I'll just sign it, and we are storing it on a smart contract. This is the page in which all the salary streams will be displayed. So as you can see, the recent one is ours, that is 259 with price 0.5 and duration of 1 month. I can buy it. And then it will also be marked as bought on this particular page. As we can see, the particular bond which was created, or like the card which was created, is now having the address of the person who have bought that particular salary stream. Now what we are doing is, like, we have came to our safe who is receiving the salary right now, and now we'll transfer our salary to the new person who have just bought our tradable cash flow NFT. So I can start initiate transactions using my Gnosis safe, which I'll be doing here. So as you can see, I have to enter my deployed contracts address plus its ABI. And the address of the new person who have bought it. And from address will be the sales address and the token ID of the tradable cash NFT, which would be 1. And then I'll initiate a transactions. And for this transaction to go through, all the person who are in one particular safe need to accept that particular transaction. So like on this safe, I have 2 wallet addresses. So for this to go through, I would require for this second address, that is OX6F14, to accept this particular transaction to go through. And then only this particular tradable cash flow NFT will be transferred to a new owner. If the second owner rejects, so then this particular NFT won't be transferred. So like this also provides a safety measure that you'll require 2 confirmations to transfer your particular salary stream. So as you can see, after both confirmations, the particular transaction will be executed. And we can also check on the transaction as that the NFT is transferred from the safe address to the new address, that is 0xAB8. And we can also check on our Superfluid's dashboard. So like the map which shows who is, in which way the particular money stream is flowing. Like if you can observe, before it was the safe address which was receiving the particular money stream, and now it's changed to the new address, that is EB88 with the full money stream. Yeah, so pretty much this was the SafeX. You can also delete your money streams from this particular dashboard. And the reason why I didn't show you the live site was that I was like doing last minute checks on this particular application, and the safe was pretty much not working fine. So because of which I have to like go for the video which we recorded. But I could show you some portions of it maybe if it's. So this page is like created for selling your particular cash flow NFT. Here, like we thought to fetch all the Superfluid money streams which are automatically minted to a user's account when a money stream is started. Here you can create or delete a particular money stream transaction. So yeah, this was pretty much for SafeX. Thank you. I hope you liked it.
Awesome, great work there. I think the first thing I saw was just that front end, and you guys always crush it with that. So really love the design of that. And yeah, like I don't think I've seen a project where you are able to manage salaries, tokenize salaries through a Gnosis safe. So to see you guys kind of like use a tradable cash flow in conjunction with this sort of like, you know, asset management and the kind of secure functionality that Gnosis Safe was really good to see. Yeah, you're basically giving like multi-signer access over a salary because it's tokenized. So I think that's a really cool use case of the salary NFTs, of the tradable cash flows. So really great work there, and congrats on the honorable mention for Waypool number 6. And yeah, I think you've been one of our most serial hackers. So great to see you come back and continue to build with us.
Thank you, Sunny, for the kind words. And yeah, I love hacking with Superfluid every month.
Yeah, for sure. You guys definitely push the limits of Superfluid. So great work there. Yeah, so that concludes today's live stream. Thank you all for coming out. And for those who are watching, I hope you guys saw a bit more of what's possible with Superfluid. We really value our hackers and the kind of developer feedback that they give us. It really helps us improve our protocol. So yeah, again, the Waypool is an infinite hackathon. It happens every single month. And so if these projects inspired you, you're free to hop in the current wave that's happening right now, the March wave. We have a co-sponsorship with Chainlink. So you can hop in and, you know, build a project that uses both Superfluid and Chainlink and be eligible for $3,000 worth of prizes. And yeah, thank you so much for watching, and hope to see you guys on a future live stream.